Hi! In my last video I promised to show you end-to-end example of training and delivering neural network on ESP32. And here it is. In this video I will tell you about how to prepare your data, how to choose your neural network for ESP32, how to train this neural network, how to set up your board, and demonstrate the work of this neural network. Okay, I think that this example can be used not only on ESP32, but also on other devices with TensorFlow Micro and Micropython. But most likely there will be some minimal changes. Okay, let's go. The best neural network to run on ESP32 is classification. Detection can also be launched, but there are too many restrictions. So we will train classification neural network. On the internet you can find already working neural network for classification, like person in the frame, face in the frame, and daisy or dandelion. I decided to teach something else, what also might be helpful for someone. And we will be training dog or not classification. For this training I took the VOC dataset, which is pretty old dataset, and split it in two classes and balanced the number of examples in these classes. Also I split small subset of this big dataset for neural network quantization. The dataset that I will be using will be available on the link in the description. Let's make a small excursion into our dataset. Here you can see the dog samples. Here you can see not dog class. And here you can see calibration dataset, where you can find the dog class and not dog class. Here you can see the model that I decide to use. It's MobileNet model with pretty low alpha. Also I append input layer that allows us to work with black and white images. Please don't use this trick in the production. Here you can read why. So, after that I remove fully connected top and switch it with average pooling and convolution. It's not typical convolution, it's convolution with one-on-one filter. With this trick we have pretty fast model, but of course with lower accuracy. As output this model have two values. One of them will be dog and one of them will be not dog. Let's move through the training process. Augmentation are not critical for such a simple task, but I decide to append them. I prefer augmentation. Also we will update the libraries with the version where there are no bugs. Next we will download our dataset Here you can see pet images folder with docs and no docs class and calibration images. Next we will append augmentation and create data generation class, which is pretty common one. Okay, next we will load our dataset and split it into test and train subset, and here you can see model creation that we already talked about, and let's start our training. There are only 5 epochs in this example, but if you have a more interesting data set, it's better to put more epoch. So after that we need to convert our neural network to TensorFlow Lite format, and in this conversion we can use calibration to achieve int8 format. Okay, we port this model and download it. After we train our model, let's spend some time with ESP32. I already talked about this in my last video, but let's repeat this. You need to install Micropython on your ESP32, and it's pretty easy to take this version that already have TensorFlow Micro. The installation guide is pretty simple. You just need to create new environment into your Python on your host machine. This environment only needs to have ESP tool. For me it looks like this. I create this environment in my Anaconda. After you create this environment, you need to flash this Micropython into your ESP32. Here you can see the command for Windows, and I think for Linux you can use something like this command. Okay. After you install Micropython to your ESP32, you need to choose IDE that you will be using to communicate with your ESP32. I prefer to use Tony Micropython, and this is how it looks like. Let's speak about our Micropython code. I took official example and modified just a bit. First we need our camera, then we append callback for our model usage and reaction on different classes. After that we load our model and start to work with our model on each image. If you have different model, you need to specify your model size here. And if you work with different image size, probably you need to change this byte array. To start our code, we need just write import our Python file here, and you need to put it on device, of course. If you want to start your example on device startup, you need to put your import into boot.py. So here we can see that our model start working, and it's take about 1 second to proceed one image. Let's show our camera some docs. Just a second. And you can see sometime it could see dock. My arms are a bit shaky, so it's not every time. And, let's make this dock a little bigger. Here you can see it. Okay, thank you for watching. All the example will be available in the description, and subscribe on my channel or on my different platform. Thank you.